So inspecting this system of equations, I see that no variable is isolated. Which honestly tells me, okay, I could do substitution, but I probably don't want to. Now I can. It's probably going to get a little messy. So no variable is isolated, which means I'm trying to, the problem's trying to tell me, don't do substitution. So I'm going to avoid substitution if I can. Okay, well, let's continue looking at the layout of this thing. I do see something pretty interesting. And to me, I think about it in stacks. So looking straight from like top to bottom. If I look in stacks, you'll notice that my x's look like they are stacked right on top of each other. 2x on top of 5x. Okay, I like that. If I keep going, the y's are also stacked up. This is also nice. Hopefully everybody else is stacked up too. Equal signs, we definitely want those stacked. They are. Okay, this is good. And last but not least, we have the constants are also stacked. Constant is just a number with no variable attached to it. Okay, so one of the other things that I note is that like terms, so things that I could add or subtract together. So like x's can be added or subtracted to x's. Y's can be added or subtracted to y's. Constants can be added or subtracted to constants. See, like terms are stacked. So one right on top of the other. This is good. Okay. Every single time we do elimination, so this method, I have an end goal, always. My goal is always the same thing. To try to perform the elimination, I would like to add straight down. And in doing so, I would like one of the variables to disappear. That's my goal. So here's my goal the whole time. My goal is to add straight down. And in that process, eliminate a variable. That's always my plan. Now, in some situations, I might actually have to do some like prep work for that to happen. But ultimately, I always want to add straight down. So this whole stacking thing is pretty important. I don't want an x and a y stacked on top of each other because I know I can't add x's and y's. So that doesn't help me. So like terms stacked, and I want to add. So I guess my question is, taking a look at this system of equations, if I add straight down, will one of the variables eliminate and just turn into 0? That the 3y and the negative 3y, when added together, will turn into 0. So I want to look a little bit more carefully as to why. So I'm just going to look at the y's. What lets me know that these two will simplify when I add straight down is the fact that the numbers, the 3's, are exactly the same. But they have opposite signs. So one of the 3's is positive, the other 3 is negative. That's the indicator for me. So going over to my goal and adding maybe a little bit of another note here, this will happen. So this can happen when the numbers are the same. but signs are opposite. And I'm talking about numbers specifically attached to a variable. Not the 2 and the 16. That doesn't help me if those numbers are the same. Actually, it doesn't do me any good one way or the other because I'd still have an x and a y. So I want the numbers on both x's to be the same, or the numbers on both y's to be the same, but I want the signs to be opposite. One positive, one negative. However, as this one is right now, I already have that. I don't have to do any extra work for it. So I propose that we add straight down and combine like terms. So if I add the 2x and the 5x, that's going to give me a 7x. If I add the negative 3y and the positive 3y, that's going to give me 0. Drop the equal sign straight down. Add the negative 2 and the 16. Take a look at our resulting equation. One of the variables disappeared. This is good. We know how to solve this equation, no problem. I don't think we need the plus 0, so let's get rid of that thing. So that's going to give me 7x is equal to 14. And I know to get rid of the 7, I'm just going to divide. 7 divided by 7 is 1, so that's 1x. And then 14 divided by 7 is 2. I don't need the 1 in front of the x either, so I'm going to go ahead and ditch that as well. Now, I have x equals. Well, I guess my question is, am I done? No. You guys know that in order to solve a system, we need a point of intersection. Now it's a lot like what we just did previously. Go back to the original equations and choose the one that you prefer. I think I'm going to pick the first one only because the numbers are smaller. Not that it matters, though. So choose the equation that you prefer from the very beginning. And then just be super careful here, folks. You want to make sure that you plug it into the right spot. We solved for x, so make sure that you plug your number in for x. So there's my 2. Take the x out. Continue writing the equation. And then I'm going to go ahead and plug the 2 in for x. Now, if you take a look at this equation is actually a little bit more complicated than the first one we had to find. Kind of a trade-off. Whereas with substitution, finding the first answer was harder and the second answer was easier. Elimination is the reverse. Finding the first one is easier and finding the second one's a little bit harder. But we know how to solve these equations, just takes a little bit more time. So if I multiply my 2 and my 2, start sliding things over to the other side. I know that 4 minus 4 is 0. Drop down the 3y. Negative 2 and negative 4 gives me negative 6. I don't need that plus 0, so let's get rid of that. Divide by 3. Know that 3 divided by 3 is 1. So I get 1y is equal to negative 2, but I don't even need the 1. Looks like y is equal to negative 2. Now I've solved for both of it. Last thing. Write your solution as a point, always in alphabetic order. So the x that we found was 2. The y that we found was negative 2. Okay, let's move on to the next one. Let's go ahead and write down the system. Inspect it. Look and see. Is this set up for substitution? So are either of the equations is a variable isolated? Or does this look like maybe elimination would be easier? looking at the stacking effect of it. Okay, I see that everything is stacked up, so I'm thinking elimination. If I add straight down, because I always want to add. I don't want to do anything else, to be honest with you. Just add. If I add straight down, I think the x's disappear. Because the 2's are the same number, but the signs are opposite. Okay, so let's add straight down. I know that the x's disappear, so I have a 0. I have a negative y and a positive 3y. That's going to give me a 2y. Negative 2 plus 10, that's 8. I don't need the 0, so let's rewrite it. 2y equals 8. Draw my line, keep these guys separated, and then we know what to do from here. Divide by negative 2, or excuse me, by positive 2. That's going to give me 1y is equal to 4. I don't really need the 1. So I just get y equals 4. From here, choose the equation that you prefer. Okay, so let's use that equation. Know that it doesn't matter which one you use. So we have 2x minus y is equal to negative 2. Remember where you're plugging this in. It's going in for y. So 2x minus, there's my 4, negative 2. I don't need the parentheses, so I can drop those. Again, finding the second one normally requires a little bit more work. Not a huge amount, though. So that gives me 2x plus 0 is equal to 2. I don't need the plus 0. Divide by 2. I get 1x is equal to 1, but I really don't even need the 1 in front of the x. Now that I have both of them, I do have my solution. Alphabetic order written as a point. So let's see. For x, we got 1, and then for y, we got 4. Now, I believe that is my solution. I believe it is. One of the things we haven't really talked too much about is, well, how can you make sure that that's actually the right solution? So, how do we verify a solution to a system? Well, you plug it in, but you got to plug it into both of them. So, plug in the point. To both equations. If what you get is a true statement, then your answer is right. If you get a false statement like 3 equals 8, then it's not correct. You made a mistake somewhere. So we're going to take this and we'll do a quick check on this. So if we have 2x minus y is equal to negative 2. The answer that we got was 1, 4. Now remember that because we always write them in alphabetic order, we know that the x is 1 and the y is 4. So let's plug it in. So for the x and then the y. When you are checking something, the variables both disappear because you're plugging stuff into it. Now you just need to make sure that what you got is correct. So 2 times 1, don't need the parentheses. And I know that 2 minus 4 is negative 2. So at this point, I ask myself, does negative 2 equal negative 2? Yep, check. That works. But you can't just plug it into one of them. You've got to plug it into both. So we grab the other equation as well. So negative 2x plus 3y equals 10. So we've got negative 2, plug in the 1, 3 times 4. All right, that gives me negative 2 plus 12. That looks like 10 equals 10. That's also correct. If both are true, then your solution is correct. If either one of them is false, then your solution's wrong. So I can think of a couple situations where I would give you, I'm not even asking you to solve the question. I just say, here's the solution. Am I right? You can check it for sure. You don't have to go through and actually solve the system itself. You can just go through, plug in the numbers, and make sure that what you get are true statements. And this is something that you guys do have coming at you pretty soon. So it's not necessarily that you have to solve it. You have to verify that the solution is correct. Okay, so question number 3. Make sure you have this written down. Same inspection idea. Take a look at it. Does it look like it's ready for substitution? Does it look like it's ready for elimination? And if it's ready, by that I mean everything is stacked up. If it looks like it's ready for elimination, the next question is, if you add straight down, that's the key here, add straight down, can you get something, and by something I mean a variable, to eliminate? Okay, so as it is, adding is a no-go. That's not going to work. But that's what I want to do. I want to add. So I do notice that I have the 4s matching. Let's just see if we can get those 4s to have opposite signs. To do that, choose one of the equations. It doesn't matter which one it is. And in order to turn that positive 4 into a negative 4, we are going to multiply the entire equation by -1. Because all I want to do is flip the sign. I don't want to change the number. But if I multiply everything by a negative, then I can get the sign to flip. I think I'm going to do the second equation. Not that it matters. So I'm going to take this entire second equation, I'm going to put parentheses all the way around it, and I'm going to distribute a -1 all the way through. And I'm going to draw that off to the side. So I'm going to do -1 times +2. Well, that gives me a -2x. All the way through, folks. -1 times +4y. That's a -4y. Equals, make sure you keep going, -1 times 2. That's -2. You notice this equation looks just like the original, except all the signs are now flipped. Now let's take the first equation and just slide it back over so they're still stacked on top of each other. So I'm just going to slide this over. Now, if I add straight down, the y's will disappear. So the only step that is different on this one is the fact that we had to get the signs to flip. Now from here, see if you can solve this problem all the way through. So I'm just going to catch up with you now. If you combine like term, we actually don't need the 1 or the 0. Looks like x is equal to -1. Choose one of the original equations. I think I'm going to go with the 3x plus 4y equals 1. Be careful that you plug it in where it belongs. And then just keep in mind that solving for the second half of this typically, not all the time, but typically requires a little bit more work. I got y equals 1. Did anybody else get y equals 1? Okay. All right. So let's write our solution then. Again, in alphabetic order, the x is -1, the y is 1. That's my solution to this system. I can check it if I wanted to by plugging it into both of the equations. Okay, last question. Take a look at it. I would like you to solve the system. If it looks like it's set up for substitution and you want to do substitution, then do substitution. If it looks like it's set up for elimination and you want to do elimination, do elimination. If you prefer one method over the other, that's fine too. You go through and solve this though, and then we'll check your answers and see how you did. Okay, so there's the worked out solution to question number 4. Double check yours against mine. Remember, you did not have to multiply the same equation by -1, but one of them had to be multiplied by -1 to be able to eliminate the x's. Then from there, we did get that y is equal to 1. Go back to the original equations. Don't use one that you changed. Go all the way back to the very beginning. Plug in what you found, and then solve for the other variable. In this case, it was x. Now, important to note, you guys, this is the kind of like when we first started substitution. This is the beginning of elimination. But the idea of being able to multiply an entire equation by -1 really does allow us to go, well, why can't I multiply something by 6 then if I wanted to? Well, you can. So we're going to start multiplying by other numbers as well. For today's assignment, though, look very carefully. It's really going to follow along with exactly what we just did in the notes. So either something can eliminate right now by addition, or maybe you have to multiply something by -1 so that the addition works.